Hey guys, just to let you know that you can catch these lessons live every Thursday from 6 PM until 7 PM UK or BST time, and that will just allow you to ask any questions that you want and get some answers to them. Without further ado, let's get on with the lesson. Okay, welcome back everyone to yet another free A-level tuition lesson for A-level maths that I'm doing live on YouTube. So these are done every single week, Thursday, 6 PM to 7 PM. And today we're going to be doing completing the square and discriminant. Now, completing the square you may have seen back in year 10 and 11, so your GCSEs, but it has slightly changed. Okay, so it can be slightly more complicated. So first of all, with completing the square, what is it? Well, it's just another way that we can write quadratic. So for example, if we have x squared plus 4x minus 3 equals 0, we can write that in a few different ways. So we can use the quadratic formula, we can factorize it into brackets, we can do all of this fun stuff. Completing the square is just another way of doing it. So you may wonder, well, why do I care? Well, the reason why you should care is, number one, there are exam questions which literally just say, using completing the square, show that or make it this. The second point is you can actually find what the minimum of any quadratic is. Which is actually pretty useful. Okay, so when you're sketching them, you can work out the minimum point without having to do some interesting nonsense. Okay, so let's work out how to do it. Well, as you know, with quadratics, we like to label the number in front of the x squared as a, the number in front of the x as b, and the number at the end as c. So for the completing the square, we have a little formula, and it's x plus b over 2 squared minus b over 2 squared, and that's it. Okay, you can say plus c if you like, but technically the plus c isn't part of the formula. Okay, so if we were to apply it to this case, we would have x plus 4 divided by 2, so 2 squared, minus 2 squared minus 3. So then expand this out, we have x plus 2, I should say, equals 0. X plus 2 squared minus 4. If you look, this is always going to be negative because you square it to make it positive, then make it negative. Minus 3 equals 0. So then you have x plus 2 squared minus 7 equals 0. And I forgot to write the 2. Cool. So we've done completing the square. You just apply this formula. Perfect. So then what else do we need to do? Or what else can we do? Well, we can also find what the minimum point is. And the minimum point is just going to be, so the minimum of this one is all you do is you flip the sign of this and make it minus 2, and you keep the other sign the same. That's it. That's how you can work out minimum points. Okay, that may not seem too difficult, but you know, it's a thing that we can do. It's somewhat interesting, and that's pretty much all there is to completing the square. This discriminant thing we'll come on to a bit later. But for now, let's do some practice with completing the square to see what we can do. So, show that this thing is true for all real values of x. So unless you do further maths, you don't need to care about for all real values. So we have x squared minus 6x greater than 0, right? So what we can do is actually, once again, use our bracket. So if you remember, we half b, so it'd be minus 3 squared minus 3 squared plus 11 is greater than 0. So now we can start simplifying. Minus 3 squared. Minus 3 squared is 9. Make it a negative, so it's minus 9 plus 11 greater than 0. Okay, now in terms of the reasoning, there's actually a few things that you can do. So the good thing about being in sixth form now, or doing A-levels anyway, is you get a bit more freedom. So one way you can prove, so if we say way number 1, is you can say that the minimum is, and again, flip the sign and keep the sign the same too. This is greater than 0. So the lowest point on the graph, so if I were to draw this quadratic out, the lowest point is at 3, 2. And I recognize that that's not in the right quadrant. Okay, it's just for demonstration. Which means it never goes into the negative. Which means it always has to be positive, which means it's always greater than 0. One other thing is, what's the smallest thing this can be? Well, the smallest thing I can make it is 0, right? Because if I make this a negative number, it gets squared and becomes positive. If I make it a positive number, it just becomes a bigger positive. So the smallest thing is 0, then I'm adding 2. Of course that's greater than 0. Both of those work. Okay, so in that case, minimum is 3 over 2, which is greater than 0, is the way I'm going to say, is the way I'm going to describe it as being greater than 0. Cool. Okay, so I'm going to hide that. What about this? Well, here we have prove that for all values of x squared plus 4x plus 12, so let's write this out. Oops. Okay. Not sure what that was about. Minus 4x plus 12. So we zoom back in. Right. Plus 12 is greater than x plus 3. So the question is here, how do we do this? Well, it would be really easy if it looked something like that. So why don't we make it look like that? So if we get rid of everything on this side, we will then have something that looks like the previous question. So we're minus x and minus 3 from both sides. X squared stays the same. Minus 4x minus x gives you minus 5x. 12 minus 3 gives me 9. It's greater than 0. And then we do the exact same thing we just did. So we have x minus 5 over 2 squared minus 5 over 2 squared plus 9 is greater than 0. You can use a calculator to work this out if you want to, because it's a calculator paper, but whoops. So why don't we choose a calculator? You don't need to, you can work it out using fractions if you prefer. We have minus 5 over 2 squared and then plus 9 on the end, which gives me 11 over 4. I'm going to leave it as a fraction because it looks a bit better. So again, if you want, you can say the minimum. Flip the sign of what's in here, you get 5 over 2, 11 over 4, which once again is greater than 0. Or you can see that the smallest this bracket can be is 0, and we're adding a positive number, which means it must be positive overall. Okay. So let's leave that as it is for now. Okay. Now let's do this next bit. Find, in terms of the constant p, the roots of the equation. This is pretty interesting. So, with completing the square, one other thing we can do is calculate answers. Right? We can actually calculate what the roots are going to be. Okay? And this question is actually saying what the root's going to be. So if I go back up to the top for a second, I have this solution here, right? I can find the roots to this equation. Now the reason why this is useful is sometimes we don't have easy numbers to work with when we factorize. So if I plus 7 to both sides, you're going to notice we get a surd, and this isn't unique for completing the square. Generally speaking, we get surds. Square root both sides, we get x plus 2 equals plus or minus the square root of 7. And then we subtract 2 from both sides, we get x equals minus 2 plus or minus the square root of 7. Now that looks like what you'd get from the quadratic formula, right? Which is the point. You can do this and get the same answers you'd get with the quadratic formula. But I haven't used the quadratic formula, and in my opinion it's a bit easier. With this question, they're basically asking us to find the solution. So we can either use the quadratic formula or completing the square. But in this case, they tell us use completing the square. So that's exactly what we're going to do. So by completing the square. So again, we just load up. We just think about how we do completing the square. We have x plus half of b, which is p over 2, squared, minus p over 2 squared plus 4 equals 0. Now let's go ahead. X plus p over 2 squared minus p squared over 4 plus 4. Now this is where it's going to get a bit spicy. Move this over to the other side by flipping the signs. Whoops. Over 4 minus 4. Okay, now we're going to square root both sides, and this is where, again, it's going to look ugly, but this is what they've told us to do. X plus p over 2 equals plus minus, remember, p squared over 4 minus 4. And what was the last step I did? I just subtracted this from both sides in the previous bit. And I normally put that first because it looks better. Okay? Just because we're doing maths doesn't mean everything has to be ugly. There you got it. Oh. Okay. Now this next part kinda ties in to the discriminant. Okay? Kinda. So this has no real roots. When this thing here in the square root is less than 0. I want you to think for a second. Think about why that is the case. Okay. Real roots is the point here, okay? So for me to have no solutions, x can't equal anything, I have to get a math error. So the only way to get a math error is if I try and square root a negative number. I.e. if this thing here is less than 0. Okay, let's try it right now, right? Like I can square root basically any number. But it breaks down if I try and do the square root of minus 1. So, that's the only way I can get a math error is if this is negative. If it's 0, I get 0. If it's positive, like any number, whatever, it still works. The only time it doesn't work is if it's negative. So real roots, when it says no real roots, it means there's no solutions, which means this has to be negative. So now let's do it. Let's add 4 to both sides. We get p squared over 4 is less than 4. Times both sides by 4, I get p squared is less than 16. And then go over here. Square root both sides, I get p is less than plus minus 4. And that's it. That's your answers. So p either has to be greater than minus 4 or less than plus 4. That's it. Not bad. Not bad. Now, the way I did this was a bit interesting. We'll go through that in a bit, okay, when we do sketching. But you can tell which side the inequality is going to take by what the graph would look like. Which... Okay. Next question. Oh God, my voice went. Okay. So, the curve C has the equation x squared plus ax plus b. And it says, given that the minimum point is 4 minus 3. Find the values of A and B. So where did we hear about minimum point? Well, the minimum point is... Whoops, I've just scrolled on the wrong thing. The minimum point was just when I swapped around these things here. So if we go up here, we flipped the sign of this and we took this to be the real thing. So let's do that. I'm going to just write what this completing the square must look like. X minus 4, because there's a 4 here, squared, and then minus 3 equals x squared plus ax plus b. Again, I'm going to go through that one more time. The reason for that is to work out the minimum, we flip the sign of what's inside the bracket and we kept the sign of what's outside the bracket. So all I've done is, using this information, is I've worked back, I reverse engineered my solution. Okay? And I say that because it sounds cool. So, what we're going to do now is expand the left side and make it look like the right side. So, x minus 4, x minus 4, minus 3. Let's expand this. I'm not going to write the right hand side for now. X squared minus 4x minus 4x gives me minus 8x. Minus 4 times minus 4 is plus 16. Minus 3. X squared minus 8x plus 13. And we know that that still equals the stuff from the top. So now you just need to compare. A is the number in front of x. The number in front of x is minus 8. B is the number on the end, which is 13. Those are my solutions. Not too shabby, I hope you find. Okay. Okay, now this is the one. So, that looks a bit weird, right? Now, whenever you see something like this, right in the form blah blah, it's always completing the square. Because it's the only way we can get something that looks like that. But this A and this 2 should spark some interest. Okay? Because when you have a number in front of x squared, you're going to have a number outside the bracket, okay? So if you remember, if we go all the way back up, there was no number in front of x squared. When we do completing the square, there has to be no number in front of x squared. So, or you can say the coefficient of x squared has to equal 1. So now, how can I make the coefficient equal 1? Well, if there's a 2 in front of it, I can divide by 2. Now, because this doesn't equal anything, I can't really divide it by 2 that easily, but I can factorize 2 out. And then what I do is I do completing the square. That's how I do the answer. So 2, and then what I like to do is when I have a bracket and then a bracket next to it, I like to use staple brackets for the outer bracket and the inner one gets the regular curved brackets. Because I think it makes it look a bit more clear. So x plus 2 squared minus 2 squared and then plus a half. Okay. By the way, there are other ways to do it. And what I mean by that is some people like to factorize just the beginning bit and leave the one outside and add it at the end. Totally fine. It's the same thing. Either way you want to do it. So 2 x plus 2 squared minus 2 squared. So 2 squared is 4. Stick a minus. And again, I'm doing this in like really slow steps. And I recommend everyone does this for now. Because again, we're not in the exam yet. We can take our time, be a bit chill. That would be minus 3.5. I'm not going to write it as a fraction, but it's 7 over 2 if you want it as a fraction, which can help. Now we expand the brackets, because look here, there's no square brackets. So we get 2x plus 2 squared minus 7. That's it. So if you want to find the values, a is 2, b is 2, c is minus 7. Not too shabby. So if we keep going, I believe... Okay, yeah. We've got a few more questions before we get onto the discriminant. Discriminant really isn't that bad. I think you'd be fine with it. But isave, let's do it. Again, this means comp square, because it's the only way we can get a quadratic in this form. So let's do it. We have x plus 9 over 2 squared minus 9 over 2 squared plus 3. Okay. So let's do this. Again, you can use a calculator, so don't really worry too much about it. But 9 squared is 81, 2 squared is 4. So you can just leave it as that. And let's get down to business. So we have minus 9 over 2 is just 4.5, so let's write it as that. Minus 69 over 4. Done. 2 marks. Easy peasy lemon squeezy. State the coordinates of the minimum point of this curve. Sorry, I just went through puberty. Of this curve. Well, it's the exact same equation as the question. So y is just equal to x plus 9 over 2 squared minus 69 over 4. So the minimum point, if you remember, you flip the sign of this, you get minus 9 over 2. And you just keep the same thing. So minus 69 over 4. That's your answer. 4 marks in about 2 minutes, if that. Not too shabby at all. Not too shabby at all. Okay. Bear with me 1 second. I'm just going to get some water before we do the next question. Okay. Okay. So, by completing the square, find the constant k of the roots of the equation. Well, let's do it. So once again, this is similar to the one we had before, where we're going to get something that's just plain hideous. Right, so completing the square gives us x plus k over 2 squared minus k over 2 squared minus 6 equals 0. Simplify this out. Minus k squared over 4 minus 6, 0. Now to find the roots, roots just means solutions. Why do they have 2 different names? It's a very good question. Moving on, move all of this to the other side except the brackets. So x plus k over 2 squared. Again, you probably remember this from GCSE. So it's good to know that there is some like somewhat easy content in A level. But it's good to go over it. Now we square root both sides and we get x plus k over 2 equals. Now the best way to do this, let's leave it just as is. Yes, you can square. So basically, keep in mind that you can't just square root these two things separately. Okay, so you can't just do square root k squared over 4 plus square root 6. It's not the same thing. So just be careful of that. Then minus the k over 2, we get x equals minus k over 2 plus minus the square root of k squared over 4 plus 6. And that's your answer. 4 marks. Not bad, I personally think. But it's not too bad. And then it says, hence find the exact roots of the equation. So, hang on a minute. Okay, this is kind of annoying. This question's missing something. It tells you what k is. And in this case, it should be 4. So I recognise the question. It should have k equals 4 somewhere, but it doesn't. I think that's my bad. But yeah, k over 4, so you just need to find the solutions. Again, this isn't bad at all. Sub in k, so minus 4 over 2 plus minus 6. I don't know why I wrote it like that. So that's going to give me minus 2 plus minus 4 squared over 4 would just give me 4 plus 6 is 10. So our two solutions are x equals minus 2 plus the square root of 10, or x equals minus 2 minus the square root of 10. That's it. Not too bad. Okay, cool. So, what we need to do now is work out, or not work out, sorry. We need to do the discriminant. Okay? So what is the discriminant? That is a very good question. The discriminant tells us the number of unique solutions to a quadratic. Okay, so I'm going to write out the quadratic formula. Cool. This formula is extremely powerful. It tells us all of the unique solutions for a quadratic, whether it be no solutions, one unique solution, or two unique solutions. By unique, I mean that sometimes you get, you know, when you sub this in and you get x equals like 4 or x equals 4. It's not a unique solution. There's always two solutions, but sometimes, you know, or it's unsolvable, but sometimes they're not unique. There's a part of this equation that determines whether or not we have 0, 1, or 2 solutions. And that is this. Now bear with me. If the thing inside, so b squared minus 4ac, if it's negative, what happens? Well, let's try it out. I'm just going to sub in random numbers, right? So let's do minus 10 plus the square root. Pick a negative number. Let's do negative 5 over 2. Oh no, math error. Because we can't square root a negative. There are no real and unique solutions. Okay? Does that make sense? Hopefully that makes sense. Now what if it equals 0? Well, if this equals 0, the whole equation collapses into just being x equals minus b over 2a. That only has one answer. So there is one real and unique solution. Because this only has one answer. The plus minus is what gives us two answers, right? Now what if it's positive? Well, you can probably guess that there are two real unique solutions. And the reason for that is when we square root a number, we get two values. So when I square root 4, right, so let's say it's positive and the answer is 4, I can have plus 4 or minus 4. So I have two different answers. So I'm either going to add 4 and then divide, or take away 4 and then divide, which has to give me 2 different answers, unless it's 0, which is what we have here. But if it's positive, it has to give you 2 answers, 2 different answers. That's where the discriminant comes into play. And you can be asked to do various things. Okay? So one common thing is it has no real roots, so find the set of possible values. Well, if it has no real roots, then that means b squared minus 4ac is less than 0. So no real roots means b squared minus 4ac less than 0. So let's sub that in. We have k squared for b, minus 4, a is 1, c is 2, is less than 0. So k squared minus 4 times 1 is 4, times 2 is 8, is less than 0. So k squared is less than 8. So k is, okay, it's less than plus minus 8. Oh, God, that was a terrible mistake. Please forgive me. Plus minus the square root of 8. Okay? Now the problem is here we have 2 solutions. Okay? Now if I draw this out, like draw this graph out, okay? It's positive, so it's going to be a U shape. Yeah? Like this. This here would be the minus root 8. This here will be the plus root 8. If I want less than, I'm looking at the bits between it. So we have minus root 8 is less than k, not equal to, less than 8. Does it make sense that it's less than and not equal to? Yes, because if it's equal to, then it will be on the line which is 0. We want negative, so less than 0. That's it. Question 1. Not too shabby at all. Here's where things get a bit more interesting. The equation kx squared plus 5x plus k equals 0, where k is a positive constant. This is now important information. So I've given a bit of a spoiler to the answer to this question. Has equal roots. Equal means that there's one unique solution. It's just another way they like to write it. Equal roots because both roots are equal to each other, so there's one unique solution, which means b squared minus 4ac equals 0. Okay. So once again, b squared, we have 5 squared minus 4 times k equals 0. So we have 25 minus 4k squared equals 0. Let's move the k squared to the other side because I don't like negatives for my variables. Then we can divide by 4. And then we're going to square root. So square root of this becomes plus minus. Square root of 25 is 5. Square root of 4 is 2. Okay. Find the value singular. Positive constant. So k equals 5 over 2. Students drop a mark all the time by stopping here. The question's asking for one value because there's one answer. Because it's a positive constant. Students every single year, all the time, always decide to not read the question properly and give 2 answers. It has to be one answer or you drop a mark. This is a 3-mark question. So you lose a third of the marks, which is bad. Okay? So just please keep that in mind. So, as for the next question, let's keep moving onwards. Just see how much... Okay, good. No real roots. Right? So, no real roots, no solutions means that b squared minus 4ac is less than 0 because we're square rooting a negative, which gives us math error, which means there's no answers. Find the set of possible values. So, again, it's a set. So, b squared, we have 6k squared. Make sure you square the whole thing. Minus 4, a is k, c is 2. 0. 6 squared is 36, k squared is k squared, minus 8k equals 0. Now what I can do here, it's not quadratic. Well, it is, but I can get rid of the quadratic by dividing by 8k. So the biggest thing I can get through both of these is 8k. Okay? Sorry, divide by k. Right, so I can cancel through by k. We get 36k minus 8 equals 0. So 36k equals 8. K equals 8 over 36, which again you can use a calculator or your brain to simplify down. Top and bottom by 4, you get 2 over 9. Now it says a set, so actually I should have wrote less than 0. That's my bad. So k is less than 2 over 9. The reason why I made that mistake just now of writing equals is I usually teach pupils that don't like inequalities to just write equals and then at the end add the inequality back. Okay? Which is fine if you want to do that. It doesn't actually change anything. But that is the correct way of doing that. Perfect. Okay. So hopefully that's all okay. Again, just stop me the second you're not sure you want me to go over it again. We went through completing the square a bit earlier for those of you that have just joined. And those are some interesting questions. And we've done the discriminant. I'm going to do a summary at the end of the lesson where I scroll through the questions so you can ask any more questions. So be sure to stick around for that if you missed the first part of the lesson. Okay, this is where it probably gets as hard as it gets in terms of the discriminant. Okay, 2 distinct real roots. So I'm just looking at that now. B squared minus 4ac is greater than 0. That's what I want to start with, okay? Now, the difficult bit is the fact that A and C are expressions which look a bit tricky, but it's actually not that bad, okay? So what we're going to do is substitute it in. B is 4 minus 4. A is k plus 5. C is k plus 2. Greater than 0. So we're definitely going to get a quadratic. So let's get down to business. 4 squared is 16. Now I'm going to leave minus 4 on the outside. K squared plus 5k plus 2k, so 7k plus 10 greater than 0. Now we can times it all by minus 4. Some students do this all in one step and they mistake and they get the signs wrong. Okay, they mistake the signs. 7 times 4 is 28. Minus 40. Now we can actually simplify this, make this minus 4k squared. Minus 28k. 16 minus 40 would be minus 24. It's greater than 0. So what we can do here is we can do something quite special. All of this is negative, so what I can do is just times by -1, or move everything to the other side, or divide by -1. But the point is I'm making all of this positive. Okay? Positive numbers are easier to work with, generally speaking. Next thing we're going to do is I actually notice I can cancel this down by dividing everything by 4. K squared. 28 divided by 4 is 7. 24 divided by 4 is 6. Now I can factorize this. Two numbers that times to 6 and add to 7 is 6 and 1. So k plus 6, k plus 1 is greater than 0. So it crosses the x-axis at -6 and -1. And now I need to know what side the inequality takes. Okay? So the way to do that is you draw your inequality, your graph out. And it's going to cross at -6 and -1. And it's a positive quadratic, so it looks like a big happy face. Okay? Because it's a positive quadratic. And I'm looking for the values that are above the x-axis. So k is either less than -6 and k is more than -1. Because I'm looking for the things or the values that are outside of this range. Okay? So outside of that range. I hope that makes sense. Okay, so this question is basically the same as the previous question. So let's go through and see if you guys retained what we're talking about. Two distinct real roots. B squared minus 4ac is 0. So we have n plus 1 squared minus 4. A is 1. C is 3 minus 3n. It's greater than 0. N plus 1 squared, we could expand that to n squared plus 2n plus 1. And minus 4 times 1 does nothing, so 3 minus 3n is greater than 0. So we have n squared plus 2n plus 1 minus, 12 minus 12n is greater than 0. So we have n squared minus 10n minus 11 is greater than 0. So you can't actually do this without using the quadratic formula. Okay, so you have to use the, or you can use completing the square. So quadratic formula, we're going to use n equals minus 10. Actually, let me write out the quadratic formula for you just to, as a reminder. Plus or minus the square root of b squared, so minus 10 squared minus 4ac. There we are. Now you could use your calculator, so that's one way to do it. Or you can actually simplify this and get the surd. Again, it really is up to you. So I can actually type this minus, wait, can I? Oh my goodness, okay. I'm learning more about this calculator every day. Plus, square root I don't know how to do on by the keyboard. Minus 10 squared. So I get, just make sure that's all. So, yeah, minus 10n. Okay, wonderful. So I get 11 or n equals. Also, one thing that really triggers me, just like use the arrow keys to go and change the thing. Oh no. I said that and now I've just messed up. No, oh god. Alright, basically use the arrow keys to change what the value was. And don't be stupid like I just was. So, right, and change it to a minus this time. Just change that. You don't need to change the whole thing and rewrite it. You don't want to be like me in this case. Don't rewrite it. It was a bad move. Wait, can I? Nah, okay. Oh, minus 1. Oh, that was disappointing. Okay, cool. And again, we're looking for the values that are above the x-axis. So, this is our quadratic. We have 11 and minus 1 and a big U shape. And we're looking for the values above 0. So that's this side and this side. That happens when n is less than minus 1 and n is greater than 11. So that's our answer. So, Lila, as for your question, I stream every Thursdays between 6 and 7 p.m. for A-level maths. And for GCSE maths, it's every Tuesday, 6 and 7 p.m. Perfect. Okay. Again, this looks like a very familiar question, right? So it should, because we're doing the exact same thing. But it has no real roots. So b squared minus 4ac is now less than 0. So what we're going to do here is we're going to write this out. So 2k minus 3 squared minus 4, 1, and k plus 3 is, whoops, less than 0. Okay, just make sure I've done that right because I got distracted. Okay, perfect. So we're going to minus 4 again, k plus 3, because 4 times 1 doesn't do anything. It's 0. Expand it. 4k squared minus 6k plus 9 minus 4k minus 12 is less than 0. Okay. Hopefully that should answer your question. Okay, so next we have to bring this all together. So 4k squared, there's no other k squared, so let's leave it as 4k squared. Minus 6k, there should be a k here too. Is minus 12k, minus 4k is minus 16k. 9 minus 12, is that right? Yeah, good. 9 minus 12 is minus 3. Less than 0. Okay, so just make sure I've done this all right. So we have 9 minus 3, that's all good. Yeah, all good. So all we need to do here is, once again, we're actually going to use the quadratic formula, okay? And it's going to be pretty damn ugly, unfortunately, but that's just the way it is. So k is equal to minus b, so minus 16, plus minus square root minus 16 squared minus 4. A is 4, and c is minus 12, and over 2 times 4. Again, let's just enter the whole thing on our calculator, and this time I'll try and not be stupid and remove it. Ah, perfect. Okay, so we can actually change this like this. I like to do the plus first. I'm actually not. Oh, thank God. All right, I took a risk there and it was unnecessary, but I did it anyway. Minus 16. Change that to a 6. Good. First answer is 2 plus root 7. You can probably guess what the next answer is going to be. Minus root 7. Cool. Now we need to work out which way it is going to be. Now you might be noticing a pattern, some of you, that are kind of fairly on it. But if you're not, then just keep drawing it out. 2 minus root 7's over here. 2 plus root 7 would be equally distant away, but actually it wouldn't. It would be slightly further away. And we have a U shape. Perfect. We're looking for the numbers under the graph because it's less than 0. So that happens between the values of 2 minus root 7, less than k, less than 2 plus root 7. Okay. Not bad. Not bad at all. Okay, so what we could do is, we might not have time for a summary if we do some more questions, but if you want a summary, keep in mind that these videos, the live streams are saved on YouTube, but I also edit a version and upload it the day after, so on Friday. So if you can't make it for the live stream, be sure to check the channel on Fridays in the evenings, and I will upload kind of an edited version, and that does help. I just realised I probably need to actually make the lighting a bit better in my room, don't I? Just to make sure it doesn't look all weird. I look like a ghost at the moment. Anyways, enough about my problems. The curve with equation this does not intersect with the equation 2x minus 12. So, when we normally talk about an intersection, right, we equate the two curves. Right? Now, seeing it says it does not intersect, this equation has no solutions, which means we can discriminant. Okay? Move everything over. We get px squared. So what I want to do here is I want to make this... Actually, no, I'm not going to do that in one step because that's a bit stupid. Otherwise, it will confuse you guys. Minus 5p equals 0. Now, this has no solutions. Okay? Now, I'm going to do something just to make the discriminant slightly easier. I'm going to factorize out a minus 1 from this and make it 4p plus 2x. And then just minus 5p is 12. No solutions means that b squared minus 4ac, as you guys are experts at, is less than 0. Good. So keep in mind, this is our coefficient c. Sorry, not coefficient, RC. B squared. Bear with me 1 second, my voice has just died. Okay, I think I'm back in the land of the living. That means we have minus 4p plus 2 all squared, because I'm squaring the minus as well. Help me. Okay. Minus 4, a is p, c is minus 5p plus 12. Should be less than 0. Yeah, this is pretty ugly, right? So, again, it's ugly, but that doesn't mean it's wrong, so to speak, okay? So if I'm squaring this, I can just make that positive, right? And then expand it out. So make that positive and then just expand it out. Minus 4p minus 5p plus 12. 4p times 4p is going to give me 16p squared. Plus 8p gives me plus 18p plus 4. Minus 4 times minus 5 is plus 20p squared. Minus 4p times 12 is going to give me minus 48p. Oh, that 4 is really annoying. I could have divided all by 4. Okay. 16p squared plus p squared gives me 36p squared. Minus 18 plus 48 is minus 30p plus 4. And then depending on how you want to solve it, you can use the quadratic formula again. Jeez, okay. Minus 30 plus minus. It's 36. Again, apologies if I'm getting a bit quiet. My voice is being punished routinely. I've got those numbers right around. Looks like I have. Well, no hope but pray. And once again, I deleted the thing because I'm an idiot. Start with plus because I like to. Whoops. God. Oh, okay, that's pretty reasonable. 2/3. And hey, look, I didn't make the same mistake again. And 1/6. So I'm hoping maybe some of you by now have noticed that when it's less than 0 and this number's positive, it's always, the inequality is always between those two values. But for those of you that might not be convinced, we have a sixth, 2/3. We're looking for under 0, so that's below the x-axis, so these values here. So again, it's going to be a sixth is less than p is less than 2/3. Okay. Geez. One other time we use completing the square is with equations of circles. And we're actually going to cover that in an upcoming lesson. So what I'll do is I'll leave that for now because we don't really have time to just go through it and like slam another thing on you. That was a tough one. So, I thank you all for coming out. I thank you all for tuning in. Again, just be sure that you're kind of here on time. Again, it's going to be 6 p.m. to 7 p.m. every single Thursday, and that's going to be UK time. The videos are uploaded the day after. No worries, Lila. Hope you found it useful. But again, we're coming on to the kind of circle theorems, like the equations of circles, a bit later. But for now, this will do again. So I hope you all have a really wonderful evening, and